I welcome all of you to the video lecture series on fluid mechanics. This lecture is on topic 1 on introduction. The topic 1 consists of 5 different subtopics. The present lecture is focused on the first subtopic, fluid mechanics. What is it, how it works, and why to study. Before presenting an eventful and insightful answer to this question, let me present some preliminaries corresponding to this subject. All of you know the commonly found states of matter. There are 3 states of matter which are commonly found: solid, liquid, and gas. And liquid and gas together is called as fluid. We are interested in studying the both solid and fluid at rest as well as in motion. And the subject corresponding to this study is called as solid mechanics and fluid mechanics. Whenever a fluid flow occurs, there are certain forces which are associated to the fluid flow. The flow occurs, there is a force which causes this flow, and there is a force which appears as a resultant of this flow. Like if you consider flow in a pipe, the cause of the fluid flow in a pipe is commonly we encounter that we use a pump so that at the inlet of the pipe the pressure is large, and at the outlet of the pipe the pressure is atmospheric, which is smaller, and the pressure difference leads to the flow. So there is a pressure difference which acts at the inlet of the pipe. However, when the fluid enters into the surface of the pipe, then along with the pressure force, there are some additional forces which acts on the flow. Those forces are called as viscous force and inertia force. So the fluid flow occurs is caused by these 3 forces: pressure force, viscous force, and inertia force. So the flow pattern which is generated inside the pipe is determined by the interaction of these 3 forces. However, once the flow is occurring inside a pipe, then the fluid flow interacts with the inner surface of the pipe, and at that surface, due to the flow, there is a force which acts on the surface of the pipe. The force corresponds to a shear force in the flow in the pipe. Whereas if you consider flow across an aeroplane, there is a lift force, and when you consider flow across an aeroplane as well as flow across a car, you encounter a drag force. If you consider this type of flow situations where the fluid is moving with a constant velocity u infinity, then what you encounter is that the velocity is uniform in space and it is not varying in time. So under this case, we find that there is no action in the fluid flow. However, as soon as this fluid flow encounters a solid surface on its path, like if there is a car which may be either stationary or moving, then the fluid dynamical action starts. In this case, you can see that the fluid passes through the upper surface of the car, and on the back side there is a flow separation which is occurring. So the fluid dynamical action starts when this fluid flow interacts with a solid surface which is either stationary or moving. And this force led through the drag force in case of a car. Now, in this flow situation, note that most of the action, when we say action as far as flow is concerned, I mean the velocity gradients and the pressure gradients are larger near to the solid surface. So we focus our attention to this region where we have a larger velocity and pressure gradients. The fluid mechanics that we'll be studying here, we will consider fluid as continuum. The continuum concept is presented here with a variable density. All of you know density is defined as mass per unit volume. However, in fluid mechanics, which we are studying here, we are defining it as we are considering a sample of fluid of volume V, and we are defining the density is equals to mass per unit volume, where the volume corresponds to volume tending to a finite size corresponding to a critical volume. It has been found that if you plot the variation of density with increasing sample volume, where sample volume is increasing from, let us say, nanoscale to micro scale, from micro scale to kilometer scale, what is found that at a very small scale, there is a fluctuation in density. And once it reaches to the micro scales, the density reaches to a constant value. And at a larger scale, kilometer scale, the density again starts varying. So from the micro scale to the kilometer scale, we find that the density remains constant. So the most of the fluid mechanics problem which we encounter in real life corresponds to this length scales. So we consider fluid, we do not study the fluid as on a microscopic level. We assume that the fluid is continuum. So we do not consider that there are certain molecule and there is a gap between the molecule. We consider, whenever we define points in a fluid region, the point corresponds to a volume which is greater than this critical volume, such that our point is continuous in space. We consider the fluid point continuous in space. So we assume that the fluid is continuum. So we are not working in this uncertainty region, shown here as microscopic uncertainty and macroscopic uncertainty. This critical volume, note that its magnitude is of the order of 10 to the power minus 9 meter cube for liquid and gases at atmospheric pressure. Now I'll present the definition of fluid mechanics. For scientists, fluid mechanics is a science to understand the behavior of fluid at rest or in motion and the associated forces while interacting with solid or other fluid at its boundaries. Note that, as I mentioned, the action of a fluid mechanics problem starts with a fluid-solid interactions, where the solid may be at rest or in motion. And the associated forces, as I had mentioned, the associated forces corresponds to two types of forces. Forces which causes the behavior of the fluid flow, and the behavior of the fluid flow results into certain hydrodynamic forces at the solid surface. For engineers, fluid mechanics is subject to understand and predict the effect of the behavior of the fluid for various engineering applications. Scientists are interested in the cause of the behavior of the fluid. Engineers are more interested in the effect of the behavior of the fluid, because once they know the effect of the behavior of the fluid, they utilize it effectively for certain engineering applications. So the effect of the behavior of the fluid leads to certain fluid mechanical forces. Like if you consider flow across a car, there is a drag force. If you consider flow across an aircraft, there is a lift force. Similarly, there are some hydrodynamic forces, aerodynamic forces which acts for spacecraft, boat, windmill and turbines. The fluid flow also leads to affects the heat and mass transfer. Like if you consider a heated object and the fluid is flowing over it, then the fluid flow affects the rate of heat transfer. If the fluid is stationary, then there is only one mode of heat transfer, which is called as conduction. Whereas when the flow starts, the additional mode of heat transfer is called as advection. And the combination of this conduction and advection is called as convection. So this fluid flow affects, the effect of the fluid flow is, it affects the rate of heat transfer. It also can affect depending on a problem, mass transfer through a fluid body in an equipment such as heat exchanger, cooling tower, boilers, chimneys, artificial kidney, and heart and lung machines, as well as electronic products. So the fluid flow is effectively utilized in cooling of various electronic products. Finally, fluid mechanics helps a scientist to answer the cause and an engineer to predict the effect of a scientifically exciting and engineering relevant fluid mechanical problem. We encounter fluid mechanics problem in nature, like you commonly see birds flight, fishes propulsion, tornadoes, hurricanes, monsoons, etc. And you also encounter various engineering applications corresponding to geophysical flow, blood and air flow in human body, aircrafts and rockets, chemical and metallurgical industry, power production, cooling of electronic devices, etc. We are more intimately associated with fluid as compared to solid because there are more fluid inside our body as compared to solid. We live in a thin layer of air which blankets the surface of the earth. There are several branches of fluid mechanics. Whenever we study incompressible fluid flow where the density is almost constant, especially water if you study, this is called as a hydrodynamics. Whereas if you study high or low speed gas flow, especially air, for flow across automobiles, aircrafts and rockets, we call that branch of fluid mechanics as aerodynamics. Whereas if you study high speed gas flows with significant density variation, then it is called as gas dynamics. Now, this slide corresponds to the second question corresponding to fluid mechanics, how it works. Whenever we investigate a fluid mechanics problem, there are two common methods, theoretical method and an experimental method. In a theoretical method, there are of two types, analytical and computational. This course is mainly on analytical. So this is mostly on analytical fluid mechanics. However, from the experiment, for certain flow situations will be discussed later, like flow in a pipe, flow across a cylinder. There have certain empirical correlation which have been obtained from experiment, which will also be discussed. The results which we obtain for a fluid mechanics problem, they are of two types. So the results or information is presented here as scientifically exciting and so the fluid dynamic information which we obtain from the results are scientifically exciting, where the actors of the fluid dynamic picture or movie are flow properties. Flow properties, by flow properties we mean velocities, pressures and temperature. So we represent our results, whenever we represent our results in terms of flow properties like velocities, pressures and temperature, then we get a flow pattern. And this flow pattern are the cause of the engineering relevant information. The engineering relevant information corresponds to the engineering parameters, such as lift force and drag force acting on a structure, pressure drop for flow in a pipe. So note that there are two types of informations. One informations which we get from a fluid mechanics problem is the velocities, pressures and temperature. This, when we draw pictures and movies corresponding to those we call as scientifically exciting pictures or movies. When we draw figures and movies corresponding to lift variation, drag variation, we call that as engineering relevant pictures or movies. So these are the two types of results or information which we obtain in a fluid dynamics study. As I mentioned earlier, that the fluid mechanics that we are studying here is a continuum fluid mechanics, which ignores the particulate or molecular nature of the fluid. In a continuum approximation, we are considering fluid property varies continuously and smoothly in space. They are associated with a continuous distribution of fluid points. In a fluid flow region, we are considering the fluid points as continuous, where each fluid point is made up of large number of molecules. The continuum model is possible since length scale involved in most of our fluid mechanics problem are much larger than the mean free path of the molecule in the flow region. This slide presents the third question corresponding to fluid mechanics. Why to study fluid mechanics? Understanding of fluid mechanics enable us to come up with a scientifically exciting and engineering relevant story of variety of fascinating fluid mechanical problems encountered in nature as well as man-made systems. So we want to develop an understanding because the results which we get from after doing a fluid mechanics study, the pictures and the movies if you obtain, they are silent, and we have to come up with a story or understanding for those results. So one of the objective of studying, why we are studying this, is to come up with a scientifically exciting and engineering story of a fluid mechanics problem. The second objective is we want to solve certain problems as an engineer for various branches of engineering, such as aeronautics, automotive, structural, mining, metallurgy, naval architecture, nuclear, and biomedical. These are the various branches of engineering where fluid mechanics problems are encountered, and there are corresponding to various fluid mechanics problems. To solve those problems, it's very important to have an understanding of fluid mechanics. With this, I had come to the end of this first lecture on Introduction to Fluid Mechanics. What is it, how it works, and why to study. These are some of the reference books which will be used in this lecture. The first book is from Gupta and Gupta, and the second is the book authored by Singhal and Singhal. Thank you for your attention.